Yeah, first of all, we need another day for another lecture. And since you are sitting here and the others maybe then are following via YouTube, I will just ask you next Tuesday, 12:15, is it okay for you? Can you look it up? Next Tuesday? Yeah, accounting. Okay. So it's every Tuesday then. So accounting. Then I had it. What's about then? Not the next, but in 2 weeks on Wednesday at 14 or 14:15. Yeah, I think it's at 26.
Yeah, it's good in Wednesday 14:15.
Yeah, but actually, if you then if there is no lecture, so I do not want that you have in parallel a lecture because a tutorial is not a lecture. And on the other hand, of course, everything here will be recorded, so you can also then use the video to recapitulate it. But question, is there a lecture? You have a lecture, but only one guy. The other ones on Wednesday, 14:15. You have also a lecture. Okay. No, I don't have it in mind, but so next Thursday is not possible. Then Thursday, 14:15. This would be then the 27th. Thursday. Academic research. Okay.
But Wednesday is much better, I think, like at
Yeah, it
14:15.
seems so that Wednesday looks quite
Because
good. Yeah.
IBS third semester doesn't have any lecture at Wednesday 14:15.
Okay, here the guy from the internet, he told me that in general the third semester in general or in the standard curriculum there is no lecture because somehow I have to find some possibility. But actually, well, I also have to look in my calendar. Then I think I will do a survey via the Moodle course, and then we see what kind of date we find in the best way. Okay, so I postpone this and I will do a Moodle um, survey for this. Okay, then let's go to the content, and we have started the theoretical part of this lecture, the so-called Keynesian economics, and especially we have started with the so-called Keynesian commodity market. And now we are within a theoretical model, and this means we make some assumptions. And these assumptions, until we relax them, these assumptions we are applying. And yeah, as I said last week, these assumptions here are very strict. And of course, in reality, we don't find these assumptions to hold in this strict way as we assume them here, especially that we are assuming that prices cannot adjust. And later on, when we look into the formulas, there we will not find any P. And the reason for this is if the prices cannot adjust, well, we can just set prices to 1. And then formally this variable cancels. Of course, in reality, prices can adjust, but we want to focus on another aspect, especially in the short run, and especially looking at labor markets. This is an assumption which is, so to speak, okay. Because especially in labor markets, maybe the main production input, especially in developed countries, they, yeah, adjust, of course, but they adjust very slowly. And also labor markets, we have seen this when we have talked about the business cycle. We have some postponement in the reaction of the labor market. If we have an economic shock, then the labor markets do not in general react at once, maybe in 1, 2, 3 months, maybe in half a year. So from this perspective, although this is a very strict assumption, in the short run, it's a quite reasonable assumption. And also within this model, we look from the demand side. If we look for a general hen and egg problem, then we say, well, the demand side is first, and the assumption is that the supply side is following the demand side and is adjusting via the production and not via price adjustments. And when we now go further until December, then slowly we will relax these assumptions. But also later on in the exam, if I pose a question, please analyze the Keynesian commodity market model and we are changing something within this model, then still all these assumptions apply and you have to argue applying these assumptions. Although in reality, we find other aspects, okay? So this is what theory is in general about. That we give us a stable framework and within this stable framework, we can analyze some questions. And this we will do today. Okay, if we have this demand side view, then we look at the overall demand, and this coincides then with our look from on the demand side on GDP. And when we have looked at GDP, this was mainly consumption plus investment plus overall government expenditure. And now I switch to something in reality. Maybe you have heard about it yesterday. Yesterday was published the forecast and the general description of the German economy by the Council of Economic Experts. And this is always done every year in the midst of November. And on my web page, I gave you the link. Oops, not this, but this one. So where do I have it? Here. Maybe there's even an English version. Let's see. So the executive summary and the press release. But we will go now in the full document. It is in German and somehow a little bit of German. You maybe can read. And there, oops, especially when you have a look in the first chapter, then you find at first the description in which state is right now the German economy. And then afterwards, you find this forecast. And let's jump to this. And then you will see um, why I talk about this, talking also about this Keynesian model. So where it is. Oop. So this is the summary, and then, yeah, the first part is about international economics, and especially you will see here, where is it? Yep, here. This is a table where you have the general estimates of the main, yeah, the large and the main countries in the world, and well, of course, the Council of Economic Advisors, they do not for every country forecast in great detail. Mainly, they are looking what the IMF or the OECD has done and then put their own view on this. Because here you see only the general forecast for the overall aggregate, the economic growth rates of GDP and inflation. These two, only these two variables. And if we go now to Germany, and this is my hope because also this lecture is about this, that you are able to read such documents and to understand what you find within there. So now is a chapter about in Germany in much more detail. And where is the forecast table? So here it is. Oops. And what do we find here? Well, at first, of course, the GDP in German Bruttoinlandsprodukt. And this is then the forecast for this year. So a slight growth. And what was for me a little bit surprising, the forecast for the next year. And this is something like a signal. It's zero point 0.9, and compared to many, many other economic institutions which have done a forecast the last 2 months, there you find yeah, a larger upswing. Not really, yeah, not really something which can be interpreted as a boom, but there most of the other economic institutions, they have here a 1.2, 1.5, and even close to 2%. So they were much more optimistic 2 months, 1 month, 2 months ago. And actually, I told also you that I'm doing with my colleagues from the Handelsblatt economic newspaper in Germany every 3 months a forecast. Well, and we are during the last year overall quite pessimistic. We have already also forecasted an economic growth rate smaller than 1% 3 months ago. And we will do our next forecast in December because also maybe it is not the best way to announce your forecast this week because next week we will get, or in 2 weeks, no, not next week, but in 2 weeks, we will get the next data point of GDP. But this, yeah, has historical reasons. This is for the last 50 years, always this is announced because they are going then. And if you look into the internet, you can also see the press conference because they handing this forecast over to the German government as a general estimation in what kind of situation are we right now economically. So overall, one can say on the aggregate, they are also not that optimistic for the future. Because again, remember this really, really large package which we have decided in Germany in March this year of 500 billion euros to invest over the next years. So there was the hope that this would mean that, yeah, the expectations for the economic performance would go up. And yeah, unfortunately, we don't see this really. And also now the Council of Economic Advisors for the next year, they are not that optimistic. Well, and then let's go to our model. What do we see here? Then we go a little bit into more detail. And the first is here private consumption. About this, we have also talked when we looked at GDP or government consumption. The next aggregate, then overall investments, and the sub-aggregates, especially construction sector. And hopefully now, yeah, you you know what these aggregates are about. And then, of course, exports and imports, so the trade balance. So this is then also from the demand side and forecast of overall economic performance. Then, of course, the next three, this is the labor market, especially unemployment, number of unemployed people and unemployment ratio. No, the next four here. And what we have here, this is the inflation forecast. And the last one is then from the government perspective. This is the deficit of the public households. And yeah, maybe you are interested and hopefully you can read and then you make up yourself your own picture. Does it match with what you are expecting in the future, or does it differ a little bit? Okay, then let's go back to our economic model. So demand side driven, we look at overall demand to be consumption plus investment plus government expenditure. And now supply side is following. So demand matches supply. Demand matches supply. And, oops, where it is, here we have assumed this Keynesian consumption hypothesis. And this is, yeah, where the mechanic of the model feeds in, because we assume that consumption is itself depending on income. So here we have the equilibrium condition, and the demand is itself depending on income, and we assume that it is positively. dependent, but an additional euro is not fully spent in consumption, but only due to this marginal consumption ratio, marginal propensity to consume, which is a number between 0 and 1. And this means then let's jump to the overall model that we assume a quite simple formula for overall demand, that this is a linear line which starts on the vertical axis given the autonomous numbers of autonomous consumption, the investment level, and the level of government expenditure. And then this is a linear line with a slope lower than 1, and the slope of this linear line is just the marginal propensity to consume. And in order to get then overall equilibrium means that graphically we also put into our diagram the condition of an equilibrium, that demand matches supply, and this we can also just interpret as a function. And since this is the identity, this is just a linear line starting in the origin with slope 1. And if the units of the vertical and the horizontal axis are the same, then the angle of this linear line with slope 1 starting from the origin is just 45 degrees. Because if you have a look in many textbooks, introductory macroeconomics, and so on, then this line is quite often called the 45-degree line. But you should also know, what does it mean? Well, it is just the equilibrium condition. These are all possible equilibria because all points on this linear line, their supply matches demand. But for demand, we have a specific curve, and so the overall equilibrium in our model is then the cut of our given demand curve with the equilibrium condition represented by the identity function. Okay, then we have also talked about stability within our model. And yeah, this is also always quite important, that we have an idea, is our equilibrium stable or not? Because in the end, of course, we want to describe the real world. And of course, in the real world, we know that the framework is not stable over time. It changes not very fast, but it changes. So always this modeling of the demand curve will shift during time somewhere else. And then it is really important that this equilibrium is stable, because if this line is shifting, then it means, well, we should move then to the new cut of these two lines. And about this, we have also talked, and we found out that this equilibrium is stable. Well, and this is then the full description of our model and what we want to do with such models. Of course, we also want then to go to the government, giving them some advice. Well, in this situation, especially of low growth rates, you have just seen that they are not very optimistic for the development of the German economy. of course, then we should do something about it. And now, yeah, given this model, these explanations within this model, we can argue what will happen if we give a stimulus by the government into our economy. And about this, we have talked with an historical example the last week, the so-called scrappage allowance. And again, this was an overall program where we tried to push the economy with a program of a volume of 5 billion euros. And what it is was, well, every guy who has given his old car away, but even a working car, and if he directly bought a new one and he have shown, well, my old car is not there anymore, then everybody has got 2,500 euros. Well, of course, that it somehow will qualitatively push the economy, this is quite clear. But when we started 15 years ago this program, then especially many economists argued against this program. Because also think of what we have talked about when we talked about the quantity theory of money. Just giving everybody some additional money, then you can argue that not really something happens to real variables, if only price is adjusting. Well, here in this model, we say prices cannot adjust. This we also have to keep in mind. But there were other arguments against it. And one argument was, well, for a car, 2,500 euro, you cannot buy a new car for 2,500 euro. So as a private household, maybe you have to invest 20,000 euros. So this is a large investment, and this could mean that I do not other large investments. And we are looking at the whole economy, and maybe we can push with this the automobile sector, but then this money is missing somewhere else. So that we have just only a substitution within the overall production. This was one argument against it, and the other one was special for Germany, because then it was argued, well, 2,500 euros, this is quite a sum if you buy a car for 20,000 euro. But in Germany, we are mainly producing large cars, which are much more expensive, 40, 50, 60,000 euros. And then relatively, 2,500 is not that much. Will it really be a stimulus for the German automobile sector, which was the idea behind? And then there was the argumentation, probably not. You will more invest into smaller cars, and smaller cars are not produced in general in Germany, but in Italy, Spain, or Czechia. So we are pushing, but we are pushing only foreign countries. But then if we're looking into the data, then we find it really worked. So incoming orders within some months, within 1 year, we had almost the level before the financial crisis. And also when we have a look at the business cycle, then we have this steep fall of overall production. And again, within 1 year, at least after 2 years, we had even in Germany a higher production level than before the financial crisis. And yeah, now we want to go into more detail because somehow we can explain what has happened there within our quite simple model. So then let's have a look. This was, or this is, somehow our starting situation. The cut of the overall demand curve expenditure with the equilibrium condition. Oops, this is German just here again. Let's, sorry for this. Keynesian market multiplier. So we want to answer the question, what happens if we, no, if we increase government expenditure, what kind of effect within our model will this have on overall income? And this relative number then we call the multiplier. And hopefully this multiplier will be larger than 1, because also if we want to ask, or if we ask, is this a good program? If we would have only a push of 5 billion euros, and in general, we do not have in the government directly the money. We have to take a credit, and then you have to repay this credit in the future. So if we push today only with if we would have a push today only of 5 billion euros, and we have to just repay this 5 billion euros, we have an overall zero effect. So hopefully this multiplier is larger than 1. And this question we want to answer within our model. So we are starting increase G by delta G, our 5 billion euros scrappage allowance. What happens then in our diagram? Where, in which curve do I find the variable government expenditure? We have just recapitulated this 5 minutes ago. Pardon? In the end, of course, this will change the equilibrium point. But I want, from you, I want to have, where do I directly find it? Well, then let's go back. Here, this is more or less the same diagram. Where do I find directly the variable of government expenditure? Capital G. Yep. Yeah, at the vertical axis, down here. So here we have C0 plus I plus G. And the only thing what we are changing is that we are increasing government expenditure by delta G. Everything else of our framework assumptions stays the same. So what happens then within this picture if we just increase this number. Yep. Yeah. And this means that our overall demand curve now just shifts upwards because now this number is increasing. So this is shifted upwards by delta G. And overall, this cut of the vertical axis would now be C0 plus I plus G plus delta G. The slope of this, and this you have to keep in mind, the slope of this linear line doesn't change. Our Cy is still the same number, so we obtain a parallel upward shift. Parallel upward shift of YD. So this would be then YD of delta G. And this you have already mentioned. This means we obtain here this increase from Y0 to Y1. Well, and now this looks graphically like this, but we have to argue, is this shift of overall income larger than this shift of the increase of government expenditure? And for this, we want to have a deeper look into this multiplier effect. So now we want to argue economically, given our assumptions, what happens in our economy when we increase government expenditure. And this we will do given our example that we say, okay, let's take this 5 billion euros. So delta G should be 5, and the propensity to consume, which is also a quite realistic assumption for Germany, is roughly 90%. So what happens? Well, of course, we have a first effect. Additional government consumption of delta G increases, of course, directly overall income. Well, actually, not here, because there, with the scrappage allowance, every single person had really to do something. In the United States, we had another program. There, we had just a payment of the government to every person in the United States, I think, if I remember it right, of 300 euros. And this was just for everybody going to their banking accounts. Okay, so this means in a first step, we have an overall increase of income. All the inhabitants of the United States, they have seen in their banking account, I have more, I have 300 US dollars more. So then this means we obtain a first increase of delta Y1 is just equal to the increase of government expenditure. Well, and if now the process would stop, then we maybe say this is not a very good program, because if this is credit financed, then we have to repay it tomorrow. And over time, there is no effect. But an increase of income, what does an increase of income means in our model. Purchase because we have assumed that we have a positive dependence of what kind of aggregate on income? Yeah, well, the income of myself have increased, but what do I assume in my model? What happens? What do I do with this additional 300 US dollars or with this additional to 2,500 euros? Yeah. Yes, of course. We have the consumption hypothesis is increasing, but we have assumed it is not fully consumed. Only 90% of my increase of income is additionally consumed. So at the second step, we obtain, let's call this then delta C2 is Cy times the first increase of the income, delta Y1, and this was equal to the increase of government expenditure. So Cy times delta G, and if we insert our numbers, 0.9 times 5 is 4.5. But consumption is also a part of overall income. We have income Y, C plus I plus G. So if consumption is increasing, then it is a part of overall income. Again, income is increasing. So this additional consumption equals to a second increase of overall income. So we have an implicit push to our economy. Well, and this implicit push in the next step means, again, we have an increase of income. What are we doing with this increase? Oh, where is our chat? There. Internet can also participate. What are we doing with this 4.5 billion euros? An increase of income means, again, yeah, 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 again, we have C is C0 plus Cy times Y. If this increases, again, consumption is increasing. So delta C3, again, but now here we have to insert, here we have our delta Y2. This is then Cy, what was delta Y2? Delta Y2 was itself Cy times the increase of overall consumption. So Cy times delta G. So 0.9 squared times 5 is 4.05. And this again is an increase of income. So we obtain a third increase. And please be careful, this is a static model, so it is not in time that this happens. It all happens simultaneously. But this is, yeah, the qualitative process which is behind this. So what do we have then to do with this third increase of income? It's a little bit boring, but more consumption, the fourth, more consumption, and so on. So this process goes on and on and on. And then overall increase of income is then just the sum of all single increases. Overall dy is delta y1 plus delta y2 plus delta y3 and so on. In our example, we have 5 plus 4.5 plus 4.05. And how did we get these numbers? Well, this was 5 plus 5 times 0.9 plus 5 times 0.9 squared. We can, by the law of distribution, this number 5 outside the bracket. Then we have 5 times 1 times 0.9 times 0.9 squared. And hopefully you remember that you have seen this before. And where have we done the same calculation in this lecture? Who remembers? Yes, this is the money multiplier. This was the increase of money in the private banking sector. Getting at the first part, at the first step, central bank money, giving a credit away, 90% of this. Then the second bank, 90% credit, and so on and so on and so on. And remember, this was then the geometric series. And although I'm adding up infinite sum of numbers, this is a finite this is a finite number. So this is again the geometric series, and this is then 1 over 1 minus 0.9. So overall increase is 5 times 1 over 1 minus 0.9 is 5 divided by 0.1. 1 over 0.1 is 10. So I obtain a tenfold push on my economy. And this here is then the effect per unit, per euro on overall income. This is then the so-called fiscal multiplier, which is just 10. And here you also see the larger the marginal propensity to consume, the larger is this multiplier. And this seems also from a qualitative point of view quite reasonable. If I directly consume more than 90%, let's say 95%, that this even pushes the economy more than if it's only 90% is also quite clear. Well, and these concept of multipliers, this is a very general concept which we find quite often in the question on theoretical models in economics. So let's define it in general. What is a multiplier? A multiplier is how much increases one, let's say the dependent variable, if another, the independent variable, is increased by 1 unit. Well, and this unfortunately again defines just a derivative. Or the government expenditure or the fiscal multiplier. This is then defined by the change of equilibrium income if government expenditure increases by 1 unit. So this is all the theory behind it. Then let's do just as a little example. Let's say the consumption function is explicitly given by 100 plus 0.1. Now the marginal propensity to consume is 80% in our example. Investment is given by 400 and government expenditure by 200. First, what is equilibrium income? Second, what is the effect if we are increasing government expenditure by 100? And the last one, we should calculate the government expenditure multiplier. And this we will do analytically, and graphically. And for this, let's go to the next slide. And well, so, and hopefully you can help me. What shall I do? What do I calculate at first? This is what we want to do in the end, but the starting point, you are always quite fast. What do I need in my model? It is a demand-driven model, so it would be maybe a good idea to calculate overall demand. What is overall demand? YD, given our explicit functions and numbers. What do I have to add up? Looking at GDP from the demand side. What have the advisors of the government yesterday added up? Yeah, idea? Oh, well, you can just go back in to your former slides. I think at 3 or 4 slides I have written it down. Overall demand is consumption plus investment plus government expenditure. Yeah. And this is then these numbers and functions I have explicitly given. So, who wants to help me? In the end of the lecture, there's a survey, And then we quite often read, well, can we do more interactive parts? And this is now an interactive part. I'm waiting. Yeah, zero point 0.8, yeah, plus 0.8y, 400, yes, plus 200. 200. So, and what else I'm doing now? Hmm, I think first we would do a, before we try to calculate our y, we do another step. If you see something like this here, 100 plus 0.8 plus 400 plus 200, doing your math, what are you doing then? Idea? Yeah, 700, of course. 700 plus 0.8 times y. Let's now jump to our diagram. Here we have yd as a function of y. Now I want to draw this function in my diagram. How should I do it? Where should I start? Yes, at 700. Yes, and it is in increasing, and it is due to the slope of 0.8 a little bit flatter than a line with a slope of 1. And this line with special line with a slope of 1, this we need also. We need also the equilibrium condition. Y equals yd. And this was this linear line with slope 1 starting from the origin. Y equals yd, the so-called 45-degree line. This was yd. And the cut of these two is our overall equilibrium. And now it's your task. Well, we use this equilibrium condition, so we have also y equals 700 plus 0.8 times y. How do I get now y star? Not the derivative. No, I just want to solve this equation. Yeah, so minus 0.8 y is y minus 0.8 y is 700. So this is then y times 1 minus 0.8 is 700. Then y equals 0.8. And this is 3,500. Thank you very much. So, first one. Second one, change in equilibrium income if government expenditure increases by 100. What is changing here in my calculations? The government expenditure, this number here, this will be then plus delta G. So I have to add just this delta G plus 100. Now it's your part. What else do I have to change in my calculations? 800. Thank you very much. So 800, 800, 800, 800, and 4,000. What happens graphically in my diagram? An upward shift. Okay. So here, delta G is 100. This would be then a new demand curve depending on this increase of delta G, and the new cut is, yeah, this I have explained 5 minutes 5 minutes ago. Well, this is just the identity function. Yeah, this is just if you have in school f of x and x, this is the function f of x equals x. So this means starting in the origin, this is also 0 plus 1 times x. This is the cut on the vertical axis starting in the origin, yeah, with slope 1. Well, and slope 1 means if the units of the both axes are the same. So if I have here 1, 1, 2, 2, 3, 3, and so on, since this total angle is 90 degrees, this has to be half of it, so 45 degrees. But of course, you have to be careful then the units of the two axes has to be the same. Okay? And therefore, if you look into textbooks, you quite often find that this line is just called the 45 degree line. But hopefully after this lecture, you also know what this 45 degree line means economically. This is the loco, the locus of all possible equilibria. Every point on this 45 degree line is a point where supply matches, where supply is matching demand. Okay, but to have the results here, y star of delta G is 4,000. So, and also, well, this is one explicit example given some specific numbers and some specific functions for the consumption function. But of course, we can also in general solve this model. If we say, well, we have yd is c0 plus zyy plus I plus g, then we equate this with the income plus g, and subtracting this part means y times mon minus cy is c0 plus I plus g, and then y star is just c0 plus I plus g over 1 times cy. So this is the general solution of this model. Still quite simple because we have a modeled consumption just with a linear function. Well, and then we have the last question. Calculate the government expenditure multiplier. What does this mean? We are going into our definition. change of equilibrium income if government expenditure increases by 1 unit. So this is analytically nothing else than the first derivative, and now we obtain the derivative of equilibrium income with respect to the variable government expenditure. Well, in general, this is, let's put it a little bit to the left. In general, this is a function depending on 4 different variables. So C0, I, G, and Cy. But now we are only interested into the dependence on government expenditure. So what is the derivative of this function with respect to government expenditure? Maybe I rewrite this a little bit. So this would be C0 plus I over 1 minus Cy plus G times 1 over 1 minus Cy. Okay, so this one here, do I find there any G? So this is just a fixed number. What is the derivative of a fixed number? Wrong. 0, yes. So I can skip it. This is a fixed number, and this is my variable. So I have a function, a fixed number times the variable. What is then the derivative with respect to g of this part of the function? Yes, 1 over 1 minus cy. No, not times. So this would be something like f of x is 3x. What is f prime? Yeah? Well, and I know, especially in Germany, we are not doing this in this thinking in variables in school anymore. And this is really a pity. Because this is then what this theoretical part is about. And especially thinking in variables. Well, quite often then we have started in lecture because we asked our students and then we got no answer. So then we always said, well, now G is X and the others are numbers, or we are doing always only these examples with given numbers for I, G, and so on. But then you do not learn to think analytically in many variables. And of course, not only in macroeconomics, also in micro, in business administration, everywhere we have multi-dimensional problems. In order to argue, when we always have to make examples with specific numbers, then it is really hard to generally argue. So also then, of course, in the end we have an exam, but also this part of this lecture is that hopefully you start to try to think in variables. Because of course the independent variable has not to be always x. And in the economic models, the variable we focus on, the variable we are changing is always changing. We also could ask, well, what happens analytically if the marginal propensity of consumption is changing. Then you have to take the derivative with respect to Cy. Okay, but if we look at this, well, what is this? This we have already seen in our argumentation. What was this? The fiscal multiplier, so 1 over 1 minus Cy, because we have assumed that in this example, the marginal propensity of consumption is Cy. So we are happy that we have obtained the same result as it should be. So then this and this we have also answered. So this is the fiscal multiplier. Okay, then before we go further, before we start to make our model a little bit more realistic, let's discuss the this the properties of this model in general compared to a model where we have flexible prices. Well, this then means in consequence that over time, so in the long run, we also can have disequilibria. So a situation where, due to the framework of the economy, we have a too low demand overall, that we cannot fully utilize especially our labor force. Well, and maybe right now in Germany we are in such a situation. We really see, if you are going outside, you always see some pictures where it said, well, we want to hire people, but unemployment is increasing right now in Germany. So there is, due to the framework of our economy, something missing. And this is then that, and remember when we have talked about unemployment, then we said, well, unemployment or an unemployed people is some guy who is willing to work, but he doesn't find or she doesn't find work. Well, and this, of course, depends on the wage rate. And here, then, we assume in general, well, that many of these people, maybe not all, but many of these people, roughly 3 million people right now in Germany, that many of them are willing to work. But since the prices not really can adjust, we can have a situation with permanent high level unemployment. Or in the other way around, that demand exceeds the capacity in the short run of production. And this would be then a situation where the economy is overheating. And overall, then this is an explanation of the overall situation of our economy where we can do something about it. Think of this push via the scrappage allowance. So we can really change the framework of our economy. Later on, when we are looking at neoclassical models, then the argumentation is, well, given 300 euros to everybody, just means that the enterprises start to increase their prices and there will be no more production. But we will come to this. But here in this model, we can do something about it. And what we then have to decide is what kind of situation are we? Is this a good explanation, or is the explanation that just prices adjust a good explanation in our time? Well, in the financial crisis, we saw it worked. In the short run, within 2 years, we were again at the same production level than before. Well, somehow we have done something similar in Germany in March, introducing this large investment program. And the first things has already started. And what we have right now, with what we have had yesterday, the Council of Economic Experts said, well, it seems that it doesn't really function. We even go down with our expectations of the performance of the economy. There will be no really upswing. So maybe this concept that prices do not adjust is right now not the right concept. Okay, but then 10 minutes left. Now we want to start to relax some assumptions or to add something in our model in order to be more realistic. And this is then called the so-called ISLM model. 1E, this E has to be behind the Y. Oops. Again, there it has to be many typos. So, still, we have no prices. Prices are fixed. We set them just to 1. Still, we have a demand-oriented model. Only quantities are adjusting. These assumptions are still valid. But now, especially in order to describe developed economy, means we have a very special good in developed economies, and this is money. So within a good model, we should talk about money. And therefore, now we are incorporating the money market. And this is, remember, when we talked about this dichotomy, this means money is the connection between nominal and real variables. And in general, yeah, we are, especially as an economist, we are measuring almost everything in money. So, and then remember when we have talked about money, we derived a money demand function. And this money demand function meant that we have a dependence of money on income. This was positive argumentation via normal goods. The demand for goods increases if income increases. Well, and to buy more goods means that we have to have more money. So money demand also increases. And the other one, a negative dependence on interest rates. This was in 2 ways. We argued from the speculative motive and from the opportunity cost motive. Well, if we now would find interest rates especially, this is now the new variable. If we would find interest rates only in the money market, then of course nothing would happen in the real market, in the commodity market. So where can we introduce interest rates into the commodity market? Well, if we look at the variable of investment. Quite often investment is financed via credit. The larger the interest rates, the more expensive are credits. So in general, then we could say we have an investment demand function, which is depending on interest rates, and it is also negatively depending on interest rates. And this is now the new part which we are introducing in our model. So we have now two markets. The commodity market, which we have already seen. This means, and there the name IS comes from, this means the equilibrium condition which we had was YD equals Y. This we can also interpret as investment equals savings, because what do we have? We have Y plus, oh sorry, not Y, oops, C plus I plus G equals Y. Subtracting these two, no, not these two, but this one and this one. This is private consumption, this is government consumption. Then we obtain investment equals Y minus C plus G. This is public consumption, private consumption, though this is overall. Consumption, well, overall income minus overall consumption is then nothing else than savings. And therefore, this equilibrium condition is the same as we say investment equals savings, and therefore we call it IS. And from this then, especially within the investment, we find the dependence on interest rates. So from now from commodity markets, we obtain a dependence between income Y and interest rates, and this is then called the IS curve. This we will derive then next week. And the commodity market, quite simple. We just match money supply and money demand. This was our money demand function depending on Y, and money demand we will set as a fixed number that we assume that the central bank can set the overall monetary aggregate. This should also be a C. Well, many typos here. And since we have here money, and there later on we will introduce prices which will be still fixed, but we have also here from the money market then also a dependence between income and interest rates, and this we will call then the LM curve. Well, at the last aspect for today, then we also want to argue, well, what is behind this negative dependence of investment on interest rates? Of course, the quite simple argument, which I gave you already, is this opportunity cost argument. Well, think of, should you invest in the startup of your brother? You have maybe from some aunt an heritage of 100,000 euro. Well, you love your brother, but you also see if I invest it at the capital markets, I obtain an interest of 2.5%. Then you think, do I get a return larger than these 2.5%? And then, of course, if this interest rate at the capital markets is higher, the probability that you would give your money to your brother for the startup will be lower. So from this opportunity cost argument, you obtain the qualitatively negative dependence. Or another argument is, let's say you start or you have a start amount of investment of an amount of A, and then you have your investment project. And then you think, what do I obtain um, because of my investment project in the future? So in period 1, I get E1. In period 2, 2 years later, I expect E2, E3, and so on. But these are future payments. But I have to decide today. So what do I then do? Well, again, remember what we have done explaining the Fisher equation. We have to value it to tomorrow. So we just divide everything what we obtain in the future by our interest rate factor. And then we can say, well, we can calculate the so-called overall internal rate of return when are our future payments divided by an hypothetical interest rate are matching our starting amount of investment. So if we equate these two, then we obtain this internal rate of return. This is a possibility to value an investment project. Hopefully you have done this in your other lecture of investment and finance or something like this. Yeah? There you have talked about net present value and so on. Is it larger than 0 or not? And here we are just equating it and we are calculating the interest rate. Well, then we maybe obtain here an internal rate of return of interest of 3%. And then we compare this again with the interest rate at the capital market. If it's larger than the interest rate at the capital market, we do the investment. If it's lower, we don't do it. And again, similar to our opportunity cost argument, the larger the number we compare the capital market interest rate, the less is the number of investment projects which I'm doing. And so then I also obtain this negative dependence. Okay, that's it for today. And next week, then we are starting with the derivation of the IS curve and the LM curve. And this, internal rate of return, this concept was also developed by Keynes and it is called the marginal efficiency of capital. So I will make then this survey and announce then when we do the additional lecture. Thank you very much for today.